guys, so today we're going to talk about compound interest. This is an application of exponential functions. This is actually how they find how much interest you earn per month, whether it be for like a credit card or if it is a savings account or something like that. So compound interest is where they use different types of values to calculate that interest. All right, so we're going to just go through a couple examples and I'm going to walk you through it, just the setup to begin with, and then we'll kind of go into individual problems. All right, so our setup problem is that you deposit $5,000 into an account. So talking about this equation that we are given, A equals P parentheses 1 plus R over N to the NT. P is my principal. Spelled different than principal, like the principal of our building. So this is the principal, and it's my starting amount. Like my initial value. Remember how we did that with those exponential functions? It's my initial value. Okay, so that's my initial value. All right, so for this one, my P is going to be 5,000. Okay, and then into an account that earns an annual interest rate of 6%. So we talked about the rate, and so what we did with this rate is we changed it into a decimal. So we moved the decimal point over 2 to the left, so 0.06. So my R stands for my rate, my interest rate in this case. Okay, so that's my interest rate. All right, determine the amount in the account after 10 years. My T time is 10. So T is the time in years. Okay, so now N is the only thing left that we haven't talked about. So N, just zoomed way in on that one. All right, so N is the number of times per year. Okay, so number of times that it'll be compounded. Okay, so compounded annually. That means it's going to happen once every year, so my N would be 1. So now what this equation did right here in the middle was it plugged in my P is 5,000, it plugged in my T is 10, and it plugged in my R is 0.06. Now the only thing that's going to change depending on what it's compounded is my N. So what I'm going to do for this middle is the amount in my account is going to equal 5,000 1 plus 0.06 divided by the N. So if it's compounded annually, the N is 1 raised to the 10 times 1. Okay, and we'll talk about calculating that in a little bit, but right now we're just going to fill in those values. All right, compounded semi-annually. That means semicircle, that's like half of a circle. So it's compounded every half year. So if we're talking for the full year, it's like every 6 months. So that would happen twice per year. So for this one, if we were to set up the account, it would be amount in my account is equal to 5,000 1 plus, now my rate is 0.06, divided by my n, which in this case is 2, raised to the 10 times 2, because my n is 2 for this case. Okay, next one, compounded quarterly. That means quarterly is there are 4 quarters in a whole, value. So 4 quarters per year. So my n is going to be 4. Compounded quarterly means it's going to happen 4 times per year. So the amount in my account is going to equal 5,000, 1 plus 0.06 divided by 4 raised to the 10 times my n, which in this case is 4. Okay. Compounded monthly. So if it's compounded monthly, that means it's going to happen every month. So there are how many months in a year? 12. So it's going to happen 12 times. So the amount in my account is going to equal, got a little scribbly there. Let me neaten that up. A equals 5,000. 1 plus 0.06 divided by 12, because my n in this case is 12, raised to the 10 times 12. All right. Couple more that we're going to go through with right now. Compounded weekly. So there are, just in case you do not know, when you get starting pay of a salary, you'll definitely know this. Weekly is 52 weeks per year. So the amount in your account is going to equal 5,000 times 1 plus 0.06 divided by my n, which in this case is 52, raised to the 10 times 52. All right, compounded daily. There are 365 days in a year. So A equals 5,000 times 1 plus 0.06 divided by 365, because that's my n for this, raised to the 10 times 365. Okay, so now we've got to talk about, because compounded continuously, you guys see how there doesn't have an n equal? Compounded continuously is totally different. So we're going to draw a little line there and hold off on that little row right there, because we'll come back to that in a little bit. Okay, so now we're going to talk about how do we type this into our calculators. So we want to type this into our calculators by doing, PEMDAS. So inside, we're going to do 0.06 divided by 1. Then we're going to add 1 to it. Then we do the exponent part. So raise to the 10 times 1 is 10. So we raise it to the 10th and we hit enter. And then we keep that number in our calculator and we do times 5,000. All right, and now remember, we don't do any rounding until the last stage of the game, where we are trying to determine our amount in the account, which is 8,954. Point, round to 2 decimal places, because money is 2 decimal places, 24, because it's 23, it's 0.238, so we round up to 24, okay? So that is how we find the amount. So we're going to go ahead and go through this next one. So I take my calculator and I do 0.06 divided by 2, and then I do plus 1 to that value. Then I'm going to do my exponent raised to the 10 times 2 is 20, so we're going to do raised to the 20, and then we're going to multiply that value by 5,000. So I get the amount in my account is going to be $9,030.56 because this was 0.556. So we round that up to 56. All right. So when you look at it, we don't change the amount, we don't change the time, which is still 10 years. We don't change the interest rate, which is still 6%. All we're talking about is that we're taking it halfway through the year and reinvesting it. So what this difference is it's just the difference in interest. So you're earning interest on your interest. So we actually wound up, earning a good amount of money by taking it at the halfway point each year and reinvesting it. Okay, so this is the power of interest. It's pretty cool to see how it changes your actual investment amount. All right, so for the next one, we're going to do 0.06 divided by 4, and then we're going to add 1 to that number. We're going to raise it to the 10 times 4, which is 40, so we're going to raise it to the 40, and then we're going to multiply that number by 5,000. And we get, now instead of taking it once a year, taking it twice a year, we're going to reinvest it every quarter, so 4 times per year. I now have $9,070. So I get $50 more just by changing the way that I invest it. So 9,070.09. Okay, sorry, $40. Trying to talk and calculate at the same time, messing myself up. All right, so on to the next one. We've got 0.06 divided by 12, because it's monthly this time. Then we're going to add 1 to it. Then we're going to raise it to the 10 times 12 is 120. So we raise that number to the 120. And then we're going to multiply that by 5,000. And I get my amount in my account is $9,096.98. All right. Now, compounded monthly is the way that most credit card companies calculate how much you owe, because they give you, your monthly statement and you see how much, interest rate you now or how much interest you now owe on your purchases. So if you notice, that's kind of why they do it. You wind up getting more money on your whatever's in your, credit card balance or whatever. They can earn interest on the interest then when they start charging you. So just kind of a little background knowledge for that one. All right. So for the next one, compounded weekly, we're going to do 0.06 divided by 52 weeks in a year plus 1. We're going to raise that to the 10 times 52 is 520. So we're raising it to the 520. And then we're going to multiply that by 5,000. So we get the amount in my account is going to be $9,107.44. All right, and the last one is 365. That means each day I'm reinvesting it. So 0.06 divided by 365, I add to that 1. Then I raise that number to the 365 times 10, that's 3650. And then we're going to multiply that by 5,000. So we get the amount in my account every single, if I reinvest my interest every single day, $9,110.14. Okay. So that is how we calculate these. So we're going to go ahead and tackle the ones where it's individual problems next.